So we're on chapter 2, the second section, and we're going to be talking about the properties and changes of matter. This is in your chemistry book. So we're going to talk about the properties of matter and physical properties, some physical properties of matter. What is a property? Property is how something that distinguishes it from another substance, right? And some physical properties that you can look at matter would be things like color, odor, density, hardness, solubility, taste, state, solid, liquid, or gas, boiling point, melting point, and all physical properties can be measured without changing the identity or composition of the substance. And then again, we have chemical properties, and they are reactions that happen that change the substance into a total different substance, like iron rusting or of propane burning. And chemical properties can be determined through chemical reactions. So two different things, physical properties and chemical properties. So let's first start talking about the changes of matter. Physical changes. Well, physical changes do not change the identity. They do not change their chemical composition. They stay the same in their chemical composition. Like a solid may melt to a liquid or a liquid to a gas and turn into steam. The chemical composition remains the same. The appearance changes, but you can change it back. It changes in shape, but you can change it back to its regular state just by temperature. And also a change in shape from heterogeneous, like we saw this picture here, heterogeneous to homogeneous. And so this actually is a physical, not a chemical state. So like sugar crystals, they settle out and then you stir it up and they melt in and they settle out later on. This, of course, is a physical change and not a chemical change. And physical changes can be reversed by physical processes. Like say you had a mixture of iron and sulfur, you can use a magnet and take out the iron. So that would be a physical change as you mix them together. So that's a change of the physical changes and changing. And we'll go on to now chemical change. Let's go on to the next page here. It talks about chemical changes. So you have those pictures there, examples of chemical changes right there. We have the rusting, fireworks, and we have on the grill, the changes that happen on the grill, chemical changes. The substance becomes a different substance with a different composition and properties. Like sodium, this is usually a really shiny poisonous metal, and chlorine is a greenish poisonous gas. But when they combine together, sodium chloride, you know what sodium chloride is? It is salt, table salt that you put on your food. It's not poisonous anymore. When it reacts as white crystallings, like this crystal, the sodium salt is required for health, actually. When sodium, you wouldn't want sodium, you wouldn't want chlorine, but put them together, it becomes something you need because it goes through chemical changes. We have rusting iron up there, the digesting of food, grilling of steaks, burning of gas, burning of a match, cooking of eggs. All of these things go under chemical changes. Chemical changes can be reversed only by other chemical changes. That means you can't change it back unless you do a chemical change, not a physical change. So if you take, say you take salt, which is sodium chloride, and you pass electric current through it, it can be reversed and go back to sodium and chloride, but you have to have electric current, and that is a chemical change. So observations, how do you know chemical changes have occurred? Well, let's go here, some 4 things at the bottom here. This is probably what you need to know. A number of observations can be made that will suggest that a chemical change has occurred. These include formation of a gas, suddenly a gas is, you're cooking something and a gas comes out. The formation of a precipitate, that means an insoluble substance. The liberation or absorption of heat, light, or some other form of energy. Some light comes out of it, glows, heat comes out of it, or a distinct change color. All of a sudden it changes color. These four things can mean that a chemical reaction has occurred. So those are the chemical and physical changes. Now we're going to go to the separation of mixtures. And we're going to talk about a process called distillation. Have you ever heard of distillation? I always heard of distillation when you're talking about distilling for alcohol or something, but let's see what distillation really is. Homogeneous mixtures or solutions in liquid form may be separated by distillation. So it's a separation if the components have widely differing boiling points. So you have here where the mixtures are a physical combination and you want to distill them. That means you want to separate them. They're all mixed in and you wonder, okay, we want to separate some of these different substances from this mixture we have. Not only a mixture, the mixture is homogeneous, and so we know it looks like it's clear, but we know that there's other substances in here. So how do we do this? Well, we separate them because some of these substances have different boiling points. So some are more volatile components first leave. So when you start getting high temperatures, some of these substances will fall out. Basically, they will distill out of them. So let me see if I can. The temperature of the mixture is raised. The more volatile component of the mixture boils first. The vapor produced may be collected, cooled, and condensed into a pure liquid, leaving the non-volatile component behind. This type of distillation is called simple distillation. Pure water may be obtained from seawater by this. So if you have pure water. So here's a picture of a simple distillation. You can see how the water is. Here we have the thermometer, how hot it gets heating up, and then certain will boil first and come off first, and then you'll receive the flask and get the distillate from that. So you're separating two different things, especially seawater, salt water from pure water is a type of distillation. So let's go on to the next. I'll show another type probably of distillation, different boiling points, and we'll have this. You see this? Okay. So let's go up further so you can see what it's called. It's called the fractional distillation. This is another kind of distillation, and several liquids have different boiling points close together. So in this way, this tall column there at the bottom, you have that basically this rotator column packed with beads there, that separate various ones out. This fractional distillation. So basically what happens, well, here's our thermometer. So here's the heating. We're heating up this, and then we have column packed with beads here, and then we have these coming off here. A certain one comes off first, and certain comes off second. So here we have this condenser coming down and the receiving and the distillation. This is called fractional. So let's go up and look more at the definition here. In mixtures of several liquids have boiling points that are close together, a process called fractional distillation. A tall column containing baffles or packed with glass beads is used above the distilling flask, and the bottom of the column is kept hotter than the top. Such a column provides a large surface area in which the less volatile components can condense and fall back into the flask, allowing the more volatile components to escape as vapor and be condensed. A similar process used is to separate the petroleum into various fractions having relatively narrow boiling points. So to separate petroleum, and that's this here. Just gives it more area. So we have more area there to collect because they have very fractional, not simple, but not so simple. Now we have fractional distillation. So, and then we have, let's see down here. Before that, we have another type here, and it's not listed. It's called fractional crystallization. And that's where basically crystals, purify solids come. One less soluble in water, and it's distilled with this hot solvent. And then the crystals settle out to the bottom and are filtered out. So we have simple distillation, fractional distillation, and fractional crystallization. These are all part of distilling. So distilling is basically separation of different components from something by their boiling points. Now, one other thing we have here, and we're going to be done with this section. So this is called chromatography. Chromatography are complex mixtures can be separated by this technique. And this technique, or where stationary liquid, or well, let's read what they're talking about. When you talk about chromatography, you're talking about color and graphia. So it's so called because in early experiments, components were identified by their color. There are several types of chromatography, most of which are based on differing interactions of each component in the mixture with a stationary liquid or solid phase. So you're going to be looking at the color of the component. One of the simplest forms of chromatology is paper chromatology, in which a drop of the mixture to be separated is placed on a piece of absorbent paper. One edge of the paper is then placed in a tray of chemical solvent, and some of the chemicals of the mixture are to be separated or dissolved by this solvent and carried across the paper, while other chemicals that are less soluble remain where they are. The solvent can then be evaporated, leaving the mixture's components widely separated on the paper. So you can analyze it as the colors come up on the paper. More advanced forms of chromatology include column chromatology and gas chromatology, which allow larger amounts of chemical to be separated and collecting. So here's a picture of it. So basically, you put the covers that put over the paper, and they're separating the components. And through the components with the paper to cover to evaporate at the original, the sample there, they come up with different colors. So these colors come up on the chromatology to tell what kind of component they are. So, and there's gas chromatology too. So that's about it for this. Let's go on to the next, see if we, yeah. So, in this here section review, it says list 4 observations that suggest a chemical change has occurred. Remember those 4 things? It forms a gas, it forms a precipitant or some substance that comes out of it. And there's a liberation of absorption of heat or some other energy that comes out, or a distinct change of color. Those are the 4 things. So, in your own words, explain the process of simple distillation. Well, I just went over that, and that's through different boiling points. So things boil at different levels, and that way you can take out that substance at the level that it boils. And classify each of the following properties as chemical or physical. So color. Well, color we know is most likely a chemical change. Corrosive, chemical change. Flammable. Flammable could be a chemical change. Color also could be a physical change too. But we have it in our 4 things. The change of color would be a chemical change. Easily oxidized, that sounds like rusting, chemical. Very dense, well, very dense could be a physical change of melting and stuff. That's a physical change. Explosive would probably be, of course, chemical change. So classify each of the following as either chemical change or physical change. So these are just properties, not changes, but properties. So a property of color, would be just a physical property of it, right? A property of corrosive would be chemical, and flammable, easily oxidized, chemical. Very dense could be a physical. So the same way, only. So classify each of the following as either chemical change or physical change. Burning of gasoline, yep, chemical. Sawing of wood, well, that would just be a physical sawing of wood. You're just cutting it up. Melting of iron. Melting of iron could definitely be chemical, depending if it just melted, iron just melted, it would be physical. So, but it changed into something else, it'd be chemical. So I would say physical. Evaporation of water, physical. We know that because it can change it right back. Sugar dissolving in tea, physical. The cooking of meat, chemical. Fermentation of grape juice, that would be chemical. Okay? So that's the end of that chapter or that section. And we're going to go on to subatomic particles in the next.